is muted.
Yeah, can you see this presentation
Yes.
screen?
Yes, I can.
Okay, that's good. Yeah. Okay. Thanks, Sudipta. As I said, we'll wait for a couple more minutes and then get started. Yeah. Okay, everybody. Again, welcome to the third webinar as part of the Research Knowledge Transfer webinar series for the project evaluating community building effectiveness of transportation investments. My name is Naveen Eluru. I'm a professor at the University of Central Florida. I have my team, my co-PI, Dr. Samiul Hasan, and my PhD student, Sudipta, who worked on this project. So today's webinar will focus on multi-criteria decision analysis for project evaluation. This is the brief outline of our presentation. I'll give a brief background on the overall project. Again, some of you who have attended the first or second seminar have seen that. I just to give you background, we'll quickly go over that, and then we'll discuss the specific objectives of the multi-criteria decision analysis that we're doing. Then we'll discuss the methodology employed, and we'll provide a summary or illustration of some of the analysis and results. Obviously, we will not be able to cover all three projects and all measures of effectiveness. So we'll focus on some specific aspects, and then we'll summarize our findings and what next from there. As all of you are aware, transportation infrastructure investments are designed to enhance movement of people and goods, and they affect various dimensions of our life and well-being, including land use, residential location decisions, and what activities to pursue and participate in. Even economic growth is closely tied with land use and transportation investments. In addition to providing pure mobility or pure movement of people and goods, transportation infrastructure projects allow connections to be built across regions. They actually serve as catalysts. A well-designed facility could increase walking and biking activities, transforming the health in the region, and also improving the community life. Further, with recent technological developments happening within the transportation space, we are moving towards a potentially true smart city, and transportation as a sector will play a very prominent role, if not the most important role, in realization of our dream of smart cities. So social media data or big data approaches, machine learning methods, and technology together can actually transform and improve the efficiency of our current cities and facilities. So even in that context, transportation investments can play a very important role. So it's important to consider these aspects when we look at new projects. So the main objectives of the proposed research were threefold. We wanted to understand what are the variables, what are the data sources that are available to understand indicators of community development. Again, from the literature, a number of indicators are potentially permissible for using for understanding how transportation impacts a community well-being, but the challenge is for some of them obtaining data is very hard. For some of them, data is available. So we wanted to identify those data sources. And then the second step, and then conduct analysis. Second objective was, how can we use social media to understand people's perception of different projects, and can we get feedback, or can we analyze these data to provide feedback to transportation agencies on what can be improved. And finally, the third objective is, can we quantify the impact of the various projects in using data we collected and we analyzed, and see if we can come up with net positive, net negative rating, so we can understand whether the project is good or beneficial, or what is the cost of the project. So to illustrate our approach, we selected three projects in the District 5 region: the Sunrail commuter rail extension, I-4, and Juice bike share. Again, we chose one public transit, one roadway project, and one bicycling project. Brief description of the three projects. For Sunrail, we had three categories of stations: phase 1 stations, which are operational and in the outside the downtown region, and stations which are in the downtown region. So these are the two regions that way. And then phase 2 stations. For I-4, we had 4 stretches of roadway as defined by the I-4 project. We have the attractions area, downtown area, Ivanhoe area, and Altamont area. So these are the 4 stretches of I-4 that we considered. For the bike share Juice project, we considered 2 areas. One is stations within downtown and stations outside of downtown. So in the last 2 presentations, what we showed was we did a series of measures of effectiveness that we computed, and also looked at social media data associated with these 3 projects. In this webinar, what we are focusing on are, we are looking at the multi-criteria decision objectives. So we want to identify community benefit to Central Florida region. Towards doing that, we wanted to look at the literature on MCDA or the multi-criteria decision approaches to find, okay, what are the appropriate methods that can be considered for our research. Once we have done the review, we wanted to go ahead and implement a framework to compare changes in MOEs across scenarios. From this framework, once the analysis is complete, our objective is to provide a net positive, neutral, or negative rating for a project. So we will we just finished documenting everything for the 3 projects. In this presentation, we'll go over the methods and we'll provide some results, but we'll also because we cannot cover all the 3 projects in this presentation, we will have an associated supporting PDF document that we'll upload if you're interested in more details about all the projects. Again, just to quickly recap, we have these 5 measures of effectiveness that we considered. So we considered property value change at a parcel level. We're getting very detailed data here. Then we have changes to job accessibility. This is what we got from Census Bureau. Then we have commuting time change. So these are measures to look at how travel times have changed, commuting travel times. Land use type change. So here we are looking at how land use has evolved. So how many vacant plots have changed to residential, industrial, and commercial land use types. And the last measure was to understand travel patterns for 0-car households. These are the different measures of effectiveness that we used to conduct our analysis. With that said, I will now hand over the presentation to Sudipta. So he will start discussing about the multi-criterion decision analysis framework. Sudipta, you want to share your presentation from your end?
Hello everyone. I am Sudipta Dey Tirtha, a PhD student working under Dr. Naveen. Now,
can you be louder, Sudipta? I think you're trailing a little bit. Yeah.
okay. Hello everyone. I am Sudipta Dey Tirtha. I am a PhD student at ECF and currently working under the supervision of Dr. Naveen. Now, I will discuss about the methodology behind multi-criteria decision analysis, and I will also present the results from our study. Multi-criteria decision analysis is a general class of operation research where we identify the best or optimal decision using a set of decision criteria. And multi-criteria decision analysis can be grouped into two classes. The first class is multi-objective decision analysis, and second class is multi-attribute decision analysis. In multi-objective decision analysis, the alternatives or the decisions are not predetermined. We will identify the optimal decision by optimizing an objective function using some variables and set of constraints. So this is an optimization problem. On the other hand, multi-attribute decision making, we have a set of alternatives or decisions. And for all of the alternatives, we have some criteria, and using the criteria, we will score each of the alternative. And based on the score of the alternative, we will find the best or the optimal alternative from the analysis procedure. And in our study, we will use multi-attribute decision making because we have a predetermined set of alternative, and the alternatives are the three projects we are considering. Now, in multi-criteria decision analysis follows a hierarchical process. In the first step, we have to define the alternative. So in our case, the three projects are our alternative. In the second step, we have to identify different criteria based on which we will score the alternative. So in our case, the 5 MOEs that Dr. Naveen mentioned are our criteria. In the third step, we have to weight the criteria. That means we have to identify the relative importance of each of the criteria. In the fourth step, we have to measure the each criteria. For example, we have property value change as a criteria in our study. So we have to find a value for property value change for all of the three projects. Finally, we have to score the each of alternative based on the criteria value and the weight of the criteria. And finally, based on the score, we will rank the each alternative, and based on that, we will find the best alternative, the worst alternative, and then the first step, we have to identify the weight of the criteria. For weighting the criteria, we can follow several approaches according to literature. The first approach is 5-point rating, where we will assign a value to each of the criteria from a scale from 1 to 5, where 1 indicates not important and 5 indicates very important. The second method is point allocation method. Here we will allocate 100 points among the criteria, and the criteria having the maximum point is the most important criteria for us. The third method is pairwise comparison method, where all possible pairs of criteria are compared among each other on a reciprocal numerical rating scale from 1/9 to 9. And in this study, we employed pairwise comparison method to compare relative importance of the 5 criteria or MOEs. So at the very beginning of pairwise comparison method, we have to define a preference rating. In our study, the preference rating ranges from 1/9 to 9. We have shown 1 to 9 here. So 1 indicates the equal importance. So if a criteria A have preference rating of 1, it indicates that the criteria A is equally important as criteria B. If the preference rating is 9, then we can say that criteria A is extremely important compared to criteria B. And using the table And based on stakeholders' judgment on relative importance of different criteria, we can create a comparison matrix where we can find relative importance between different criteria. For example, uh, for criteria 1 and 2, the relative importance is 4. So we can say that the importance of criteria 1 is moderately important compared to criteria 2. So similarly, we can get the relative importance between the criteria, and based on this matrix, we can compute the weights for each of the criteria. So for doing that, we have to uh, normalize the values of this matrix by the column sum for each of the matrix. Uh, so first of all, we are normalizing the 4 by 4 matrix here, and then we will sum each of the rows to find the priorities for each of the criteria. So if we sum the first row, we'll get the priority for criteria 1, and for other criteria, we'll get the priorities. And we have to make sure that the sum of the priorities are 1. To do that, we have to normalize the elements of this column by the sum of the column. And here is our normalized priority. And from the normalized priority, we can say that criteria 1 has the maximum priority and criteria 4 has the minimum priority. And these are the weights for the 4 criteria. And then now we discuss about different methods that can be applicable for multi-criteria decision analysis. There are several methods available in literature, and weighted sum method is the most basic and mostly used method, and we performed weighted sum method in our study, and I will discuss in detail about weighted sum method. The next slide. In weighted sum method, we have to follow 3 important steps. Firstly, we have to weight the criteria, and for weighting the criteria, I already discussed about 3 available methods. And in our study, we used the pairwise comparison method. And after identifying the weights, we need to score the criteria. And in our study, we scored the criteria based on the case and control scenario. And finally, when we find the score and the weights of the criteria, we can score all of the 3 alternatives or projects. And based on the score, we can rank the project. So for example, we have 4 criteria and we have weights for each of them. And for each of the project, we have the values for the criteria. And by using these criteria values and the weights, we can calculate the weighted average for criteria value for each of the project. And this will be our scores. And based on scores, we can see that project B has the maximum score and project A has the minimum score. And using the score, we can rank them as 1, 2, and 3. And this is the basic method for weighted sum methodology. And now we'll go to the analysis part. So in our study, I already mentioned we used weighted sum method, and we selected 5 MOEs as the criteria. And we used all of the steps for weighted sum method in our study. First of all, we weight the criteria, then we measured the criteria, and then we scored the criteria. So to find the weights of the criteria, we performed an online survey to receive FDOT officials' response. And in the survey, we asked for different questions. We basically asked for the relative importance of different criteria compared to other criteria. For example, in question 1, we asked for relative score of job accessibility, commuting travel time, land use change, and travel pattern change compared to property value. And similarly, we asked for different questions in the survey. And we collected 22 responses in the survey. And based on the survey, we prepared a comparison matrix where we can find the relative importance of different criteria against other criteria. For example, the relative importance of job accessibility compared to property value change is approximately 5. So after constructing the comparison matrix, we can calculate the weight of the criteria. So first of all, we normalize the values, then took the row sum, and then we normalize the column to find the final weights. And here is our final weights. And from the values, we can say that travel pattern change has the most important criteria, and the property value change is the has the minimum importance. And after finding the weights, we calculated the value of the criteria. To find the criteria value, we scored the criteria based on percentage changes of them in case and control area from 2011 to 2017. For example, commuting travel time in case area for Samiul project are 25 minutes and 20 minutes in 2011 and 2017. So the change is 5 minutes, and the percentage of change is 20%. And commuting travel time in control area are 30 minutes and 28 minutes in 2011 and 2017. So the change is 2 minutes, and the percentage change is approximately 7%. So the difference between change in case and control is 13%. And finally, if we know the investment for Samiul project, say for example, 1,000 million, the score of the commuting travel time will be 1.33% per 100 million of investment. This is how we computed the value for commuting travel time for Samiul project. So this was a demonstration. Now come to the property value change for Samiul station. So to calculate the property value change, we compared the changes in case and control. So in property value change in Samiul project, we have 3 regions: downtown, outside downtown, and phase 2. And for each of the region, we have 5 land uses. For each of the land uses, we calculated the property value change in case and control area. And then we normalized the change by the total of the change and express it in percent. So here is the percentage change in case, and this is the percentage change in control. Then we took the difference of them, that is 18%, and we calculated the value for each of the land uses. And we also know the share of the land uses for downtown region. And finally, we calculated the weighted average of the percentage change, and that is 35%. And this is for the downtown region. So we calculated the same thing for outside downtown region and phase 2 regions. And after that, we took the weighted average of this percentage change using the investment in different region. And the value was used as the score for property value change. And now come to the job accessibility. In job accessibility, we identified the increase of accessible jobs in case area and in control area. And then we normalized them by the sum and expressed it in percentage change in case and in control. And we took the difference of them, and this is the difference. And then we took the weighted average based on the investment in different region. And the final value is minus 2.38% per 100 million of investment. So here we can see that the job accessibility actually decreases due to Samiul project. But this result doesn't make sense, because a transportation project should increase the job accessibility. So we took the value as 0 for our final analysis. Now come to travel time change. In travel time change, we identified the percentage reduction of travel time in case area and the control area. And then we took the difference of them. And then we took the weighted average based on the investment in different region, and the value is minus 0.52% per 100 million of investment. Now come to land use change. In land use change, we considered the change of vacant area in case and control. Then we found the percentage change in case and the control and took the difference. And again, we make a weighted average, and the value is 6.62% change per 100 million. So we can say that due to Sandal project, vacant area has been changed by 6.62% for every 100 million of investment. Then come to zero curve travel pattern change. To calculate the travel pattern change, we identified the change of public transport share in case and in control area. And similarly, we found out the weighted average, and it is 0.47%. So we can say that share of public transport has increased by 0.47% for every 100 million of investment due to Sandal project. And then we'll calculate the overall score for each of the project. Initially, we calculated the weight for different MOEs, and we also calculated the values of different criteria, and taking the weighted average of the values, we'll find the overall score for each of the projects. And from the value, we can see that the Sandal project and I4 expansion project has a positive outcome, and Jewish bike share project has a negative outcome. And Sandal project is the highest score project, and that's why it is ranked as 1. And I4 expansion project has a rank of 2, and Jewish bike share project has a rank of 3. And this is all about the results, and the summary of our presentation will be presented by Dr. Naveen. So thank you everyone, and if you have any question, you can feel free to ask.
Thank you, Sudipta. I So as Sudipta presented the results, what I'll do is I'll summarize the findings. So what we did in this part of the project was we looked at multi-criterion analysis, and we developed measures to understand overall performances. Sudipta has presented, we have shown the results of the 3 projects. The results show that Sunrail project provides the highest score across the 3 projects we investigated and for the measures we used. And Juice Bike Share project has the lowest score. And we also found that I4 expansion project was also has a positive rating. In this context, while we rigorously conducted this analysis, we wanted to highlight some aspects before we can say that this is what it should be done for other projects. Again, we understand that every project is different, and we need to recognize that our emphasis of this research effort was on identifying a methodology and framework for conducting analysis. So we did an extensive data compilation, and we also analyzed that data, and we developed the most appropriate multi-criteria analysis method that is required. But what is needed is there is some caution to consider the fact that there is subjectivity in the process. So we are not suggesting that every project that is conducted by FDOT should use the same measure of effectiveness or the same change criteria that we employ. We selected, we reviewed the literature, and we thought these were relevant in discussions with the project manager and the FDOT team. But we do recognize that MOEs will affect the results. So there has to be some judicious selection of MOEs. For example, we selected property value, we selected accessibility, commuting time, travel patterns, and so on. But there's a case to be made to say that we should have selected something like a public health based MOE. For example, number of people walking and biking because of Sunrail project. That could be an interesting measure to actually consider and evaluate. But as most of you are aware, getting data on that at a very detailed level every year or even every 2-3 years is tricky, because such data is harder to collect and is not easily readily available. So our procedure and our framework development was guided by what can be done by using publicly available sources, so that we are not putting additional financial and otherwise other resource constraints on the DOT to conduct this analysis. So as and when data is available easily in these structures, we can modify the measures of effectiveness. So that's what we wanted to clearly stress, that there is no rigidity associated with the framework. What we want to do is we illustrated it with 5 measures of effectiveness, but those 5 can be replaced, can be reconsidered. We can tailor them as appropriate. I think that is important to notice and recognize, because we don't want to portray that these are the 5 measures of effectiveness and they take care of everything that needs to be done. Okay. Uh, in that context, as I said, if data was the constraint for us, but when data availability becomes easier, we might want to expand the measures of effectiveness under consideration. And also another important aspect to note is, as Sudipta mentioned, sometimes you get results that are counterintuitive. For example, whenever we are doing analysis of data, we cannot predetermine the results. So in the Sunrail project for job accessibility, we ended up with negative values for job accessibility after Sunrail project was implemented. Again, a lot of changes happen in the urban region. So when a project like Sunrail is implemented, you expect job accessibility to increase or have no change at all. So the negative result that is obtained is a result of the intrinsic complexity in what we are trying to analyze. So when such a result happens, we need to be careful in how we use it. So either we use our judgment and say this is not possible, probably it should be 0. So we that's what we did in this project. We said the value should be fixed to 0, and we proceeded further. Another, again, if there is abundance of time, another solution that you can think of is, okay, maybe this MOE is not reflecting the impact of Sunrail very well. Is there another alternative measure of effectiveness that we can consider? Again, the idea is not to predetermine the result and do it. We're not suggesting that, okay, we expect Sunrail to have a positive effect, so we need to find something like this. But there has to be a judicious discussion after some results like this happen. So in this case, we decided to use a 0 value because for us it did not make sense. Again, it depends on the different projects in context, and the solution there could be different for different projects. Another important thing to note is, again, juice system was very small spatially compared to the other 2 projects. So again, whenever you're doing analysis of such small projects, you have to be careful in the sense that the data that we are looking at, we can be more confident of larger projects because we covered a larger sample of data. When we looked at parcel level data for Sunrail, for example, we covered a stretch of more than 20 miles. So we covered a lot of property value, a lot of commuting analysis that we did. So we were more confident on that data because of the sampling properties. But when you use data for a system like juice, we are forced to consider a very small spatial area. So the number of sample points for our analysis are small. So we need to be careful. Again, we are not saying our methodology can be wrong. The methods are correct, but given the large variation that can happen, you need to be cautious with the result. Same thing with the land use change measure of effectiveness. So in our case, we noticed that changes from vacant to other were the most prominent. So vacant to residential, vacant to multifamily, vacant to commercial or business were the most prominent. We tried to look at other changes. So for example, if single family changed to multifamily, if residential changed to commercial. So, but we found that over the years, those changes were very small in the study region that we looked at in for our projects. But in other regions, they might be prominent. So instead of focusing purely on vacant to other land use type changes, if data permits, we might want to look at changes between land use types. So if residential changed to multifamily, or multifamily residential then changed to commercial or retail. So again, that's a restriction based on the data that we have for the region that we are focusing on in the district 5 region. Depending on your context, those are dimensions that might be of value for conducting estimating the MOE and then conducting your project evaluation. So these are some important things that need to be looked at when we're translating the approach we developed for application. We do not suggest the use of this method blindly or just as a direct transfer. What we'll suggest is these MOEs are good. These MOEs are good guidance. If the data is available for all these MOEs, and you think that if the project that you're considering is relevant from this MOEs perspective, you can use these 5 MOEs. But before we finalize the project and the approach, we would suggest taking a step back and looking at, okay, what are the MOEs we want to consider for our project evaluation. Again, obviously we can consider hundreds of MOEs, but we don't suggest that. But it is always a good practice to do a little bit of a brainstorming and finalize the MOEs rather than directly taking all the 5 that we used. So that's something that needs to be carefully done. Again, the MOE selection is driven by data, whether data is available, how complex is the analysis, can this be done for the project under consideration. So those are obviously considerations that need to be looked into before making the call. And once the MOEs are selected, how we're computing change needs to be carefully looked into. And then when the change is measured, you also have to look at the results of that change. So are the results making sense from an engineering and judgment point of view, not purely the number. So sometimes because of the complexity involved, the results might not match with what we expect. So again, these are words of caution that we want to suggest, so that when you use the approach, it's not a software and you click and you get an answer. You need to be careful at the end to make sure you're using your judgment to make the final call. So in terms of the next steps, so we finished the research component of it and the knowledge transfer in this fashion. What we're going to do is the 3 webinars that we conducted, and the material for those webinars will be uploaded on our website. So we will be posting the presentation PDFs. We'll also be posting the supporting documents in terms of, for example, for the GIS analysis, we developed a detailed picture grab file to show the steps for each data analysis component. We will be posting that. We'll also be posting the reports, final reports associated with the project on the website, and the videos, and also supporting videos that we created, so that things that we could not show in the webinar in the 1 hour time, we are adding those also. Again, it will take us a little bit of time to prepare this. Maybe in the next 2 weeks, we will do this, and we will share the website with all the members that we contacted, and we will also send a survey with the website information. So if you can take the time to go quickly and review it and provide some information. Again, some of you obviously listen to the videos and you're participating in the webinar directly, so you had the opportunity to see what we're doing, and we'll really appreciate your feedback, again, for the research team and for the DOT also, on what is the value of a technology transfer effort like this. How can we improve it so that in the future we can consider the feedback and provide customized webinars in that context. So with that said, we are open to any questions that you might have to discuss on the project. there seems to be okay. So Ryan, don't mean to put you on the spot. So would you be okay if we upload the recent deliverable that we submitted to you as an associated document for the third webinar? Is that okay with you?
Yeah, I think that should be okay.
Okay. So we will. I just looked into posting this. I was initially thinking about uploading them as videos, but I realized downloading from my website on my web page might not be a very good option. So I figured out a way to upload them on YouTube so that it's easier for everybody to just um, YouTube optimizes the streaming better. So we'll upload them on YouTube and provide the links, and we'll store for the DOT's purpose. We will provide the videos as video files, so they're there with us and with DOT, but they'll be uploaded on YouTube, and hopefully it's not going anywhere for a few years, so it should be available for a long time. Okay, if there are any other questions. Okay, it looks like there are no questions. So if there are no questions, again, thanks everybody for participating in the webinar series. I know some of you were present for all the 3 webinars. We really appreciate your attendance. And again, if you ever have any questions, you have my email ID. Feel free to reach out with me or my team members, and we will try to get back to you with best answers we can provide. Again, I would like to thank Ryan in particular, and also the DOT team for providing the funding for this project, and also uh, their regular feedback and insights on the work that we were doing. With that said, again, thanks again, once again, everybody, and look forward to interacting with you in future research or meetings. Okay, and
Thank you,
stay
Naveen.
safe. Thanks, everybody.